Oh, good. I have started grading the quizzes, so you can check to see if maybe I've graded yours by now. I don't know. We'll see. I'm not quite halfway done yet. So far, I think the average is at 80 something. 83. That's pretty good. Okay. Are there any questions from homework or anything? General questions?
Is number 9 from homework 5.6 the numerator on that factorable?
Nine. Yeah, what? Can't be, right?
Right.
The only way to make the positive 4 is 3 and 1, but you can't have them have the same sign. Yeah, you're right. You're right. But who cares? So why on number 9 does it not matter? Oh, yeah, I'll do that. That's a good question. Why on number 9? Let me show you number 9 real quick. Well, I'm not even going to show it to you. The instructions say find a domain. So why don't I care about the top and if it can factor?
None of them cross out. It wouldn't matter if anything crossed out, right? From the numerator or the denominator.
The fact that it doesn't factor means I'm not going to have any holes, right? Yeah. But yeah, so that's the only thing I care about. You're right. I'm only focused on the bottom as far as figuring out, and the top not factoring is awesome. I have a question about slant asymptote, and I like the way you spelled asymptote. Sorry, this is a little private chat. So, a little bit of statistics. All right. So when would I get a slant asymptote? When would I get one of those things? What would have to happen? Hello?
The top, what is it? Exponent would have to be higher than the bottom.
Yes. So if I had something like, so how do I find this slant asymptote? Your favorite thing. Just the rest of the class is going to be me standing here with my thumb on.
You divide?
Yes. Yeah. And what really sucks, can I use synthetic?
No.
That's a trick question. Yes, you can. Do I want to? No. 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 So, yeah, you got to do long division. And then, yeah, whatever you get, I really want this, I want everything to make sense. I don't know why I keep saying I want this to make sense. So I'm going to do this a little quickly. So this will be x, then I get x cubed minus 3x squared, change the signs. That's x squared plus x. So that'll be plus 1, x squared. Where am I at? I should have brought the -1 down. Oh, yeah, that's right. What did I just do? Oh, I see. Jeff, you should probably go a little bit slower, buddy. That was not working the way I thought it should. X times -3 is -3x. There you go, Jeff. That's why it's not a bad idea to put a 0 up. So when I do this, I change the sign, the -2x squared plus 4x. Then I can do, let me go ahead and do -1. Let me stop for a second. I was going a little too fast. I'm just doing long division. Got to be careful there's no x term, so I have to line up my like terms. -2, that's what I need now. -2x squared plus 6. Change the signs. We have 4x. This part doesn't matter with shit because as x gets really big, this part goes to 0. That's my slant asymptote. Done. And then what's the slope of it? What's the slope of my slant asymptote?
Four?
Say again?
Is it 4?
No.
Would it be the x minus 2 is the slant?
Yeah. So that's my slant asymptote because that piece went to 0. So the whole idea here is still the same idea as what gives us horizontal asymptotes. It's what's happening when x gets big. So what happens to this when x gets big? This piece goes to 0. So eventually it's going to follow this. What's the slope of this?
1.
1.
1. Oh, right, there you go. So if you have any questions asking you what the slope of the slant will be, find the slant and you can see it. I like it. I like it. Somebody's telling me 84 and 87 on 5.6. Oh yeah, dude. All right, that was creepy. So this problem here, this is the one we're talking about? Okay. Open box with a square base is to have a volume of 108 cubic inches. So. These kind of problems, you need to bring in, well, they actually give it to you. They're being a little bit nice. They gave you one of the variables, right? Oh, let me stop sharing. So look at this problem. And then I'm going to stop sharing so I can do this up on the board. All right, so I want a volume of 108. It's got a square base, and they want me to let x be the length of the side of the base. So, and it says find the dimensions that will have minimum surface area. Kick ass. All right. I would like this problem. So I do a quick little. Woohoo. And it said it has a open box. The hell does that mean? We're going to find out. With a square base, and they tell me that the length of the side of the base is x. Is that all the variables I need? What else do I need?
The height?
Height. I like it. So be really careful. They didn't say it was a cube. You can't make that x also. I need to give that some other variable name. All right, let me stop for a minute. So I don't know if any of you guys like this. This will help. What do they tell me? What do they straight up tell me? What do they just tell me directly? No riddle.
The volume
Sorry.
is 20, right?
Volume is 108. I'm looking at number 84.
Oh, thanks. There you go.
I think it was 84, yeah. Yeah, so the volume is 108. And what is the volume of this, units? Who cares? For right now. Right now, units. What is the volume of this shape that I've drawn?
X squared times h.
Yeah, length times width times height. So x squared h equals 108. So that is what they tell me. That's a relationship between my two unknowns. And then they ask me surface area. It's an open box, so there's no top. That's what that means. So now I'm about to stop because I don't want to do this whole problem for you. But what's the area of this side here?
X times H.
X times H. And now you just work your way around and you got a bottom. You got 4 sides and a bottom. You get your surface area formula. Is it going to involve X and H? Yes. That sucks. So then you can use this guy. I would probably solve for H. Right? If you solve for X, that'll suck. You'll have square roots in there. Does that get you in the right direction? Is that? So you want to create the surface area formula. So that's just one side, and now you add in the other sides in the bottom. And there's your surface area formula. And you want to minimize this. I like it. And by the way, notice it says use a calculator because this is going to be way more than quadratic. So these are the same kind of problems we did when we were doing parabolas, remember? And we had to use the vertex formula, the negative b over 2a, to find the minimum or the maximum. This one says use the calculator because it's going to be more than a parabola. It's beyond our ability to work with by hand. If you take calculus, you can do all this shit by hand. Yeah, and you're like, oh, here's your part. I don't know if that helps with 87. Yeah, 87 is the same idea. It's just the volume formula is different. Now, what is the surface area for a cylinder? This is not as easy. These were easy because they were flat surfaces, no problem. This is, oh shit. So it's got no top. So the area of the base is easy. But what the shit is the area of the rest of the surface? Does anyone have a clue how to do that?
Would it be like the circumference times the height?
Yes, because, now watch, this is kind of cool. Can you imagine, have you ever taken the label off a soup can? I mean, back in the day, they used to, you'd mail them in and you get some shit in your box tops from your cereal or whatever. All right, so if I cut this down and I open it up, how long, it becomes a freaking rectangle. Isn't that cool? And how long is this? Sure, circumference. And how tall is this? Sure, the height. So this area will be 2 pi r h. That's that surface area. So you would add these two, that would be your total surface area formula. They tell you what the volume is supposed to be. I don't know if you guys remember, I'm pretty sure we did a volume of a cylinder before. Wasn't I doing the whole thing where the circle, you go through the volume and all that kind of shit? Yes? Maybe? Okay. All right. That should be enough to get you going on. It was 84 and 87 in 5-6. Anything else?
How do you find the inverse of a polynomial if it's like f as a function of x equals x squared minus 6x plus 3? Like question 30 on 5.7.
Oh, okay. Whoa. Okay. Oh, yeah. So, well, let me see. If they gave you an example. So watch what we can do. I don't know if they gave you an example. Where was it again? 30? So let me do 29. And you're all like, sure, man. That way I can actually do it all the way out. So 29 gives us this. And that tells me it's going to restrict the domain to be -2 to infinity. Which if you, now watch, why does that make sense? What's the vertex of this dude? This is not something they're asking. I'm just doing this extra.
It's -2.
That's part of it. I like it. Because you would do negative b over 2a. So -2, who cares?
0.
Yeah, so this sucker has got 0, 0? No. It would be negative, it would be 4 minus 8, -4 plus 1, -3, I think. But it doesn't matter. So it'd be a -2. So this would be on either side of -2 is what would make sense, right? Because if I cut it here and use one side or the other, then it will pass the horizontal line test. So their domain being -2 to infinity makes complete sense. All that stuff was beside the point. It didn't ask you to do any of this. This is just Jeff doing weird shit. Does anyone have any idea how to do? If you just do this, you will go a little insane. No, I've done that too early. If you do this and you stare at this, you will go a little insane, but we actually know how to do this. If I subtract 1, what can I do with this to kind of put it together? It's pretty cool with what I've done so far, right? I brought the y back. I switched the x and y because I'm trying to find the inverse, right? Not a big deal. It just happens to be a more disgusting problem. What can I do with this to make it more?
Factor out a y.
No, that won't get me to a point where I can solve for y. So let me just tell you. Complete the square. Let's see what happens if I complete the square. What do I add to complete the square?
4.
Plus 4. So I can just do that directly to the other side. That kicks ass. And then this factor is like this. Now can you solve for y? And now you got to consider this and what that means in terms of these plus or minus. Right? So let's finish this out because this is actually not. So to just do this without knowing yet which way I'm going to go. Is that cool? I kind of did that quick. Square root, subtract 2. So let me put it like this. If the domain of the original function is -2 to infinity, the range of the inverse function is supposed to be what? We know this.
-2 to infinity.
Yes, because all the x shit and the y shit switch, which means domain and range switch. So that will help you figure out whether or not to choose a plus or a minus. Will it?
It should be positive.
Yes. Should be positive so that you go increase. I want to increase from -2. So I got to add positive shit to have it be at minimum -2. I like it. So now do the same thing with 30. Oh, neat. All right. So now I got a question from, any questions on that before I leave it? I mean, this is maybe not necessarily something that would come right to mind, but it's because we're not used to, but I know how to solve for this variable when it's in this, I complete the square. So it's kind of like, there's no number here, but all right, that's enough of that. 5, 7, number 57. I like that. So over allergens, help me, Jeebus. Let me see. Let me share this real quick. So an object dropped from a height of 600 feet has a height in feet after t seconds like this. Express t as a function of height h and find the time. Oh, okay, okay. So what's the, all right, so let me write some stuff down and then I'll stop sharing. I'll give you guys time to read that through. So get t is a function of h. And then find the time to reach height of 400 feet. Okay, so let me stop sharing. So real quick, I don't know if you guys have noticed this number comes up a lot when they talk about droppings. If they've ever talked about dropping something from a building or something. And it's got to do with the acceleration due to gravity is 32 feet per second per second. So anyway, physics, you cut it in half when it's in front of the t squared. So that's where the 16 comes from. Did you have to know that? No. Do I care? No. I'm going to tell you anyway. Is there from the fact that the physical nature of this problem, is there an inherent domain restriction? When is this? Oh, sorry, go ahead. Sorry.
It has to be positive because you can't have negative time, 0 or infinity.
You can have negative time, but we're not going to go there right now. But before 0 seconds, nothing has happened. So then the function doesn't exist. At least it doesn't follow this function, right? So that's what's a little more important, because there could be a function where you can have negative time. It doesn't mean physically negative time. I'll stop. In this problem, this function only exists after 0, or starting at 0. So that's not something I have to impose. That's because of the physical nature of the problem. That domain is there. So now this is invertible because that allows it to pass the horizontal line test. Because that's what this question wants you to do. It wants you to solve for t. Is that enough? Can you do that from there, person that asked the question? Okay. That helps, knowing that there's a domain, because otherwise how can you find the inverse of a non-invertible function? That's kind of evil. So once you get this, then the input is h. So that'll be, you just throw a 400 and see what the hell you get. Okay. All right. Are we all out of questions on homework? Looks like it. Maybe. Okay. Oh. So this thing said, I just got a question. This thing said I'm dropping it off this, well, it doesn't even tell me. I'm just 600 feet in the air, right? So I'm Homelander, and I picked some civilian up and I'm gonna drop it. Shout out to anybody watching the boys. In feet after t seconds have elapsed. So before I drop this thing, this person, before I drop them, they're not moving. They're not gonna follow that function. Does that make sense? That function only exists, only describes the trajectory starting at 0 seconds. Does that make sense? Okay, I like it. All right, good. Let me see. Where did I? Oh, yeah. So let's get back into some exponential stuff. I don't see any more questions coming in. So, quick thing about graphing exponential stuff. That's a lot of writing to me. All right. So if I have a function 3 to x. All right, so we did one like this before, but my anchor points for this. So you want to add this shape to your toolbox of shapes that you know. So we know x squared, we know x cubed, we know square root, we know, what else do we know? Become a thing. Wow. We know absolute value. What am I forgetting? So now we know exponential. Wow. So we're going to add that to our shapes. Now, guess what we're going to do after we graph this? We're going to graph. We're not going to graph anything, sorry. We're going to graph transformations of this. Because every transformation we learned works no matter what the hell the function is. It doesn't give a shit what the function is. So everything you've learned is the same, thank God. It doesn't change for the function. So how do I graph this? My anchor points for exponentials, for me, maybe it can be for you too, is -1, 0, 1. So when I plug a -1 in, what do I get?
1/3.
Good, 1/3.
Yeah, 1/3.
He's chatting at me. Am I missing something? Sorry. Hold on. Old man using technology. There you go. Oh, no, that's old. Okay. 1/3. And then when I put a 0 in.
1.
Put a 1 in, I get 3. It's great. Now, you could do more, but if I know the shape, I don't need as many points. I just need some anchor points. So this is going to look like -1, 1. So 1, 2, 3. So -1 is 1/3. 0 is 1. 1 is 3. And then I can, now what's happening? What's the other component of the shape that I kind of need to file away in my toolbox? What else? What is happening here? What exists here?
Asymptote?
Yes, and why is it that? Because even if I do -1 trillion, is the output 0 yet? 3 to the -1 trillion is just 1 over 3 to the trillion, which is not 0. I don't care what number, what big ass negative number you put here, it's not going to be 0. It's going to be crazy close to 0, which is exactly what an asymptote is. So it's going to get arbitrarily close to the x-axis, and then it's going to grow. You just make that big. All right, so that's the shape. So what if I did this in red? What if I had this function instead? Good Lord. 3 to the x minus 1 minus 2. Graph on the same graph. What are the shifts in this function? What are the shifts related to this function?
It would be moved down to?
Yes, that's the second thing I would do.
And 1 to the right.
Right, good. So you kind of follow order operations, right? You do powers first, and this. So the order of the shifts does matter to some degree. So I take every point. Now let's do the asymptote first, because that's going to help guide me with some other stuff. Which one of those is going to affect the asymptote?
The moving it down to?
Yeah, so now the asymptote's going to be here. So now I can take my points and do those things too. So I got to go right 1, down 2, bound. Right 1, down 2. Why am I trying to be Alex Jones? Math is insane. Right 1, down 2. And then I just fill in my shape. Weehaw. How can I check that? Does anyone remember how I can check that? What point is this?
2, 1.
2, 1. So when I plug a 2 in here, I better freaking get 1, right? So when I plug a 2 in there, I get 3 to the 1 is 3 minus 2 is 1, yeah! So whenever you do a shift, you can pick a point you go through in the new graph and make sure it works in this shifted function. That's a quick check. right, I like it. Yeah, let's do another. Let me see if I can push one more shift on top of this bad boy. We'll just do one little shift here. What happens to that guy? I don't even know if that shows up as a different color, barely.
Is it reflected across the y-axis?
Yes, because that's with the x, so it's going to reflect. I don't even know if that makes sense. That makes sense to me. If the negative was in front of the 3, it would go this way. But the negative in front of the x, so it's going to go that way, around. It goes around the y-axis. I don't know how to explain it to you guys, but that's what happens. All the x's that used to work to make this happen is now going to be on this side. Because the first thing I do is change the sign. So all I have to do is just flip the points. So that goes over there. That stays right where it is. That goes over there. The asymptote stays right where it is. So then I've got, oh crap. Jeff, stop finding. Don't go through strange points. Okay. Oh, that is a point. I do want that. I think that's as much as I want to throw on one graph. So just realize all your shifts that we learned about still have the same effect. They don't care what the function is. So as long as you know the basic shape of it, I can do shifts. Okay. That's not bad, right? I mean, that's barely new stuff. All right, so let's go back in the book and make sure Jeff didn't skip anything he's known to do. Sometimes I like to say it's on purpose, but most of the time it's not on purpose. All right. Blah, 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 blah. Blah, 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 blah. Blah, 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 blah. Oh, I do want to say one thing. Here's something interesting. What happens when the base is less than 1? I'm going to erase all this business. Okay. Am I recording this? So what happens if I have 0.25 to the x? Here's an interesting question. There's a better way to write 0.25.
1/4.
Yes. And then how can I use that new shape to do something we just did? What's another way to write 1/4?
4 to the -1.
Yes. So this becomes 4 to the -1 times x is -x. And now I know how to do it. I can graph 4 to the x and then just flip it. So when the base is less than 1, so if I have a function of this form and the base is less than 1, it effectively means it's going to have this shape. It's going to be decreasing. Which only makes sense because what happens when you multiply a number less than 1 times itself? It gets smaller. So as you increase the exponent, the results get smaller and smaller and smaller. That only makes sense. Why is this one kind of a, so what if b equals 1? What happens then?
It's a straight line.
Yeah, it's a straight line. It's boring as shit. Yeah, so it's going to be, it just becomes f equals 1. Who cares? Okay. All right, I like it. I like it. So that was one thing I wanted to do. Let me see. I don't think I missed anything. They make a really big deal out of the whole shifting thing, and it's not that big of a deal for us. We've done it before. It's the same thing. I don't care about that. Let's see. There's the reflections, and then they make a huge deal again. Okay, that's enough. Blah, blah, blah. All right. Sorry, I'm keep sniffling. It's crazy. Let's see. So I do want to, okay, I want to get back into logarithms, and then I'm going to let us out of here. Yeah, maybe a little bit early. So I really don't know how much exposure you guys have had to logarithms. So when I say that, can you click the yes button if that sounds familiar? Have you guys done logarithms before? So everybody remember what the yes button is? That's good. Somebody's chatting yes to me, I like it. Yeah, you can put no too if you want to. How many have never? Go ahead and hit the no. Okay. All right. This makes me worried about how many people are actually here. It's been 10 years, I understand. Okay, that's good. A little informal poll. We'll close it. Even if you've used them before, very often I hear students say that they hate them, that they suck. And they're so beautiful. That's not just because I'm a complete geek, but I really want you to see how simple they are. They are really, really simple. So what we did before was we had the function. Let me see if I can recreate this kind of quickly. Is that a good color to use? Can you see that? No. Yeah, okay. So if I do this real quick, I'm going to use my 3 anchor points. So at 0, it's 1, at 1, it's 2, and at -1, it's 1/2. So there's this function. And then if I graph the inverse, I would graph, instead of, so if I kind of give myself some points to work with, that would be nice. So if I do the opposite, 1/2, -1, 1, 0, and 2, 1. And the asymptote, we talked about this before, becomes this. Because when you invert, it flips. So now it looks like, oh crap. Okay. So that's the look of it. That's one thing. But now we got to figure out, I don't want to just call this F inverse and have to give somebody this. I want this to have its own function. Sort of like if I had x cubed, don't we have a function for the inverse? Right? Cube root. Become a little one. A little tiny 3, there you go. Now, real quick. When I say what's the cube root of 8, you can't like do that instantaneously, but you can do it really, really quick, right? What's the cube root of 8?
2.
2. Because what's the question you ask yourself?
What cubed equals 8?
Yeah, what does it take 3 out to make 8? So we've internalized the question that this symbol represents. But what this accomplishes is instead of having to just do this and say, well, there, I want a symbol for the operation that will undo this. I want a symbol for it. So the symbol they chose, I think I showed you this before, I can't remember. The symbol they chose for the opposite of this function, or the inverse, is log base 2 of x. So think of the word log, it's the worst thing ever. But oh well, right? You don't want to have too many functions that are like little words, but oh well, we do. That's just like the square root symbol. Instead of a square root symbol, I have 3 letters. It could have been a box with a little 2 here. That could have meant log base 2 of x, but oh well. They didn't like that. So here's the idea. What is 2 to the 3rd power?
8.
8. So log base 2 of 8, the question this is asking is the opposite of what this does. What power does 2 need to become 8? So of course this would be 3. So let me say that again, because this is the key. This is it. This is everything about logarithms. The same thing we do for roots. We just have internalized the question. we don't even think of it basically really in English necessarily. So we're learning new vocabulary. So you're probably going to have to think of this in English. So if I have log base 3 of 27, what is the question it's asking? Let me tell you, this is still kind of new for us, I understand. 3 to the what power is 27? That's the question it's asking.
3?
Yeah. So the answer to a logarithm is always an exponent. Why does that make sense? What's the input for an exponential?
An exponent.
The power. Yeah, exponent, which is, you know, why we call it what we do. So the input of this function is a power. So of course the output of the inverse will be a power. So of course the question this is asking is what power do I need? And they put the base down here. So what power does this guy need to become this? So let's do a few more. So what is log base 10 of 1,000?
Three.
And to be really honest, this is the last time I'm going to write this base like this. This is what's known as the common, I want to call it the common law log, but it's just common law. It's sort of like the square root. We don't put a 2. So for the common log, we don't put a 10. Why would that be the one that gets that special treatment? Because our number system is based on 10. Too bad every other number in existence, right? So that is 3, of course, because that's the power this needs to become this. All right, let's get a little bit freaky here. What about, what's log? Let me see if I can, let's do this in a very measured way. Let me do a series of these. What's log base 3 of 9? That's nice.
2.
2.
Because, and I'll put next to it the reasoning. Because 3 squared is 9. 3 squared is 9. You can always kind of follow this to make sure. What's log base 3 of 3?
1.
Great. Because 3 to the first power is 3. What's log base 3 of 1?
0.
Yes. 3 to the 0 equals 1. What's log base 3 of 1/3?
-1.
-1, kick ass, because 3 to the -1 is 1/3. Okay. I like it. I like it. I really wish I would have picked a different base, but let's do that. Notice if this is more than the base, it's going to be a number above 1. If it's equal to the base, 1. If it's 1, it's 0. And if it's a number below 1 here, but not negative, this can't handle negative inputs, the outcome is negative because it must be this flipped somehow. I like it. I like it. All right, here's the freakiest one yet. Put it up here. Leave this up here for a minute. What is log base 8 of 2? This is related to a problem we just did a little while ago.
Is it 1/3?
Kick ass. So this is the reason I wish I would have picked a different base here, because I can't really do. So a number, now watch. A number that's in between the base and 1. So log base 3 of 3 is 1. Log base 3 of 1 is 0. So log base 3 of 2 has to be some kind of a radical. It's got to be some kind of fractional power, because it's got to be between 1 and 0. So log base, let me do this with log base 8. If I do log base 8 of, watch it, 64, it's 2, log base 8 of 8 is 1. Good job, Jeff. So let me put this there for a second, and then log base 8 of 1 is 0. So of course this answer has to be between 0 and 1. So if the input is in between the base and 1, it's got to be some kind of a radical, a fractional power. And of course it's a 1/3 because the cube root of 8 is 2. Kick ass. Is that, hopefully I'm not going too fast, but I really want to get it across that logarithms are not difficult as long as you internalize the question the symbol means, just like we have with radicals. We don't even think about it with radicals. And it is very much like learning a foreign language, because that's what math is. Okay. So let me show you one more example, a little bit freakier, and a process to use to figure it out. So what if I have log, you can do it, John. Yeah, sure. Log base 16 of 32. What the shit? This is funkadelic. Now watch how I can do this though. Watch what I can do. Do I know what the answer is? No. So what am I going to call it? X. How can I rewrite this now?
16 to the x equals 32.
That is the basic idea of logarithmic expressions. Is it's going to be the base to the power equals this. Okay, Jeff, wow, good job. That helps. But yes, it does. Are these both based on the same number? What do I mean by that? Sorry.
Yeah, they are.
What number?
16.
No, I appreciate that. So not multiplicatively like that, but exponentially based on the same number.
2.
4.
Yes, that's 2 to the 4th. And that is 2 to the, that's right. So I get 2 to the 4x equals 2 to the 5th. So what must be true about these? What's got it? 2 to this equals 2 to that. So what must be true about this and that?
They have to equal each other, don't they?
Yeah. They have to be equal to each other. Right? That's the only way 2 to this thing can equal 2 to that thing is if this and that are actually the same. And then I get 5/4.
That was pretty cool.
I thought so. So can you make the base based on the same number all the time? No. Too bad for us. So we'll have to eventually learn some more shit to be able to handle when that happens. We don't know that stuff yet. Obviously, we're just starting out. Okay. I think, let me look at one thing and then I'll see if I can let us out of here. Oh my goodness. Doesn't matter. Talking about my nose. But my nose like 2 minutes later. Let me see. Make sure I didn't forget anything. Oh, cool. All right. We're a little ahead. All right. That's cool. All right. Good. They do a pretty decent job of showing you exactly what I was talking about. Base to the power equals the inside. Yeah, I think that's a good place. I am, you can't tell, but I am crazy tired, so I'm fine with stopping. And hopefully I'll have all the quizzes graded by later tomorrow. I don't know if I'm going to grade much tonight. So if I'm not done with your quiz yet, I'm sorry. But some quizzes have been graded, so you can take a look. Okay?
Professor?
Yes.
So so this morning I took the quiz and I submitted it at like 9. And then I like rushed off to work. And
I got your email.
Oh, you saw that?
I haven't had time to parse out. There are several students in weird situations. So I need to figure out what to do.
Okay, no worries.
Yeah.
I just didn't know if you'd seen it or not, or if you got it.
I did, but I was trying earlier. I thought I might have a chance to finish the quiz, and that was really insane to me to think that. So that's what I was focused on earlier. I got to catch up with a few people in a few weird situations.
Okay, no worries. Thank you.
Sure. How's everybody else? Anybody else need to hang out? You guys good? You can head out if you don't need anything from me. Or if you do need something, let me know.
Okay, I'm gonna head out. Thank you.
See you later, Doug.
Thank
you. Have a good day.
You too. All right, I'm gonna head out. Oh, thank you. Bye.